Are we going? There we go. We're going. Math for college technology, adding vectors using a scale diagram approach. So a vector is something that has a direction and a magnitude. So if somebody walks somewhere a certain distance, that's the magnitude or the size. If they walk north, that's the direction. So a vector quantity has to have both of those characteristics to be considered a vector. Now we can actually represent vectors using scale diagrams. And so it's a lot like algebra, but instead of using numbers, we just use drawings. Did I say drawings? I did. Okay. So here's an example. We have two vectors, and they're the same kind of vector. In this case, they are force vectors, which I don't know. We maybe learn a little bit more about them later. So Ashton's pushing a box with a force of 400 newtons. So Newton is a unit of force. And he's pushing it to the east, which I guess would be this way. So he's pushing it with force 400 newtons to the east, and Alyssa pushes the box with a force of 400 newtons to the south. Okay, so these are both vector quantities. The magnitude is 400 newtons. Ashton's direction is east, and Alyssa's direction is south. When we're doing a scale diagram, using a scale diagram approach, we just make sure that we write down what our scale is. And so in this case, 1 centimeter on my meter stick is going to represent 10 newtons. And so 400 newtons is going to be 40 centimeters. I recommend that you do this on grid paper. It's just super easy. Okay, so I'm going to start out with Ashton. He is pushing with 400 newtons to the east. And so I don't have the benefit of grid paper, but knowing my scale, I'm going to make the vector that represents Ashton's force. There we go. Normally, we say north is up. Uh-oh, I'm pushing west. Ashton's pushing west. Yeah. Yeah, that's right. He's going east. Okay. That's the problem with Ashton. He's always pushing the wrong way. Okay. Anyways, there's north. And that's usually east. Okay. Alyssa is pushing with a force of 400 newtons south. And so using my ruler, and if I had nice grid paper, this would be just slightly easier. But because they're at 90, it's really pretty nice. Okay. So there we go. 400 newtons east. There's 400 newtons south. When we add vectors, if we're doing it with a scale diagram, and I recommend that you always draw them no matter how you're doing it, we add them tip to tail. And what we want to know is what is the net force on this box. So Ashton's pushing in one direction, Alyssa's pushing in the other direction. This box is going to move somewhere in between that. So we add tip to tail like this, and we literally draw our vector like that. Now, we have the good fortune of these being at 90 degrees to each other. And so if I really wanted to be accurate, I could use the Pythagorean theorem to find out what the magnitude of that net force is. But that sounds like extra work. What I'm going to do instead, I'm going to take my meter stick and I'm just going to measure it. And it's about 59 centimeters in length. And so since I'm using a scale diagram, I can actually just say that this is 590, not 59, 590 newtons. And the next thing I have to do is I need to figure out my direction. Giant wooden protractor. And I'm going to, you probably already know what this angle is, but I'm going to pretend like as if I don't know, and I'm going to measure it with the protractor. Look at that, it's 45 degrees. What a surprise. Okay. So get rid of some of this stuff. I don't need this anymore. Don't need this anymore. This is 45 degrees in here. This is going to be enough to get me a direction. So for now, this is 45 degrees. And the way we indicate this direction is And we can almost pick anything, but we're going to pretend that we're facing east and then we're rotating towards the south. So I start out by saying east, which means I'm facing east. And then I write 45 degrees and the direction that I rotate towards, south. Okay, so that's adding vectors, a scale diagram approach. Choose a scale, draw your vectors, measure your angles, measure the result, and that's all you have to do. Scale diagram approach, vectors, super simple, but powerful.